High in the snowy expanse of Alaska, where the land meets the sky in a seamless white horizon, a sleeping giant is stirring, breaking the silence of the frozen wilderness. Mount Spurr, a volcano long dormant, has begun to show signs of unrest. Steam rises from its peak, a subtle yet ominous signal. This majestic peak, towering over the surrounding landscape, is sending out signals that are impossible to ignore. The once tranquil mountain now whispers of potential chaos. Scientists at the Alaska Volcano Observatory are closely monitoring the situation. Their vigilance is our first line of defense against nature's unpredictability. They are analyzing data from a network of sensors, each one providing crucial information about the volcano's behavior. Their findings suggest that Mount Spurr could be on the verge of a major eruption. The data points to increased seismic activity and gas emissions. The implications of such an event are far-reaching. An eruption could send ash clouds high into the atmosphere, affecting areas far beyond Alaska. An eruption could disrupt air travel, impact local communities, and force evacuations. The lives of many could be turned upside down and have lasting effects on the environment. Ashfall could devastate crops, contaminate water supplies, and alter ecosystems. The time to prepare is now. Emergency plans must be in place, and communities need to be ready to act swiftly. Understanding the risks and heeding the warnings of scientists is crucial. Public awareness and education can make a significant difference in response efforts. We must respect the power of nature and be ready to respond to its awesome forces. The awakening of Mount Spurr is a reminder of the dynamic and ever-changing planet we call home. The first clue that something was amiss came in the form of earthquakes. These tremors, though initially subtle, were the harbingers of a much larger story unfolding beneath the surface. Seismometers, designed to detect even the slightest tremors in the earth, began picking up an unusual pattern of activity beneath Mount Spurr. These instruments, sensitive to the faintest vibrations, started to record a series of small but persistent quakes. These were not the massive, ground-shaking earthquakes that often make headlines. Instead, they were smaller, more frequent quakes that seemed to be happening with increasing regularity. These smaller quakes, while not immediately alarming, were significant in their persistence. The continuous activity suggested that something unusual was occurring deep within the Earth. Yet their persistence and location were a clear indication that something extraordinary was happening deep underground. Scientists began to pay closer attention, analyzing the data with increasing scrutiny. As molten rock, known as magma, rises through the Earth's crust, it stresses the surrounding rocks. This movement creates pressure, which is often released in the form of earthquakes. This stress is released in the form of earthquakes. The pattern of these quakes can tell scientists a lot about what is happening beneath the surface. The increase in seismic activity around Mount Spurr suggests that magma is on the move, pushing its way towards the surface. This movement is a critical indicator of potential volcanic activity. Scientists use the frequency, intensity, and location of these earthquakes to track the movement of magma and assess the likelihood of an eruption. By closely monitoring these signals, they can provide early warnings and potentially save lives. Another telltale sign of volcanic unrest is the release of gases. Volcanoes act like giant chimneys, venting gases from the Earth's interior. As magma rises, it releases gases like sulfur dioxide, carbon dioxide, and water vapor. These gases can escape through cracks and vents in the volcano's cone, creating plumes of steam and gas that are visible for miles. Scientists use sophisticated instruments to measure the composition and volume of these gas emissions. Changes in the ratio of different gases can provide valuable clues about the state of the magma below. Increased gas emissions, particularly sulfur dioxide, often precede volcanic eruptions. This is why monitoring gas releases is a crucial part of volcano monitoring. Imagine the Earth's surface as a giant balloon. As you inflate the balloon, it expands and deforms. The same principle applies to volcanoes. When magma accumulates beneath a volcano, it can cause the ground surface to bulge or deform. This deformation can be subtle, often only detectable by sensitive instruments like GPS receivers and satellite-based radar. Scientists use these instruments to create detailed maps of ground deformation around volcanoes. This information, combined with seismic and gas emission data, helps them to build a more complete picture of what is happening below the surface. Significant ground deformation can indicate that a large amount of magma has accumulated, increasing the potential for a large eruption. Section 5. Echoes of 1992, Mount Spurr's explosive history. Mount Spurr is no stranger to explosive eruptions. In 1992, the volcano roared to life, sending a massive plume of ash and gas high into the atmosphere. This eruption, though relatively short-lived, served as a stark reminder of the volcano's destructive potential. The ash cloud from the 1992 eruption drifted over Anchorage, the state's largest city, disrupting air travel and blanketing the city in a layer of fine volcanic ash. The 1992 eruption provides valuable insights into Mount Spurr's eruptive behavior. By studying the deposits from this eruption, scientists can better understand the types of hazards to expect from future eruptions. This knowledge is essential for developing effective emergency response plans and mitigating the impact of future eruptions. Section 6. Anchorage on alert, preparing for the worst. The city of Anchorage, home to nearly 300,000 people, lies just 80 miles northeast of Mount Spurr, a potentially active volcano. This proximity to an active volcano poses significant risks to the city and its residents, making it essential for the community to stay vigilant and prepared. In the event of a major eruption, Anchorage could be impacted by ashfall, mud flows, and even volcanic gases. The ashfall can blanket the city, turning day into night and creating a hazardous environment. Ashfall can disrupt transportation, contaminate water supplies, and pose health hazards. It can clog engines, damage electronics, and make roads impassable, creating a logistical nightmare for emergency services. Mud flows, a mixture of volcanic ash, debris, and water, can travel at high speeds and cause significant damage. These flows can destroy buildings, sweep away vehicles, and pose a severe threat to anyone in their path. Recognizing these risks, city officials and emergency management agencies are taking proactive steps to prepare for a potential eruption. They are working tirelessly to ensure that the city is ready to respond effectively. This includes developing detailed evacuation plans, stockpiling essential supplies such as food, water, and medical kits, and educating the public about volcanic hazards through seminars and training sessions. Public awareness and preparedness are crucial for minimizing the impact of a volcanic eruption. Community engagement and participation in drills and educational programs can make a significant difference in ensuring safety and resilience. Section 7. Eyes on the mountain monitoring and early warning systems. Thanks to the tireless efforts of scientists at the Alaska Volcano Observatory, Mount Spurr is under constant surveillance. A network of seismometers, GPS receivers, and gas sensors provides a steady stream of data, allowing scientists to track the volcano's every move. This real-time monitoring is essential for providing early warning of an impending eruption. The AVO uses a color-coded alert system to communicate the level of volcanic unrest to the public. Green indicates normal activity, while yellow, orange, and red signify increasing levels of concern. In the event of an impending eruption, the AVO will issue timely warnings, allowing authorities to take necessary precautions and residents to evacuate if needed. Section 8. Ash in the air, health and environmental hazards. Volcanic ash, though seemingly innocuous, poses significant health and environmental hazards. Composed of fine, jagged particles of rock and glass, volcanic ash can irritate the eyes, skin, and respiratory system. It can also contaminate water supplies and damage crops. People with pre-existing respiratory conditions, such as asthma, are particularly vulnerable to the effects of volcanic ash. In the event of ashfall, it is important to stay indoors, wear a mask if venturing outside, and avoid driving if possible. Volcanic ash can also have long-term environmental impacts, altering soil composition and affecting air quality. Understanding these hazards and taking appropriate precautions can help minimize the risks associated with volcanic ash. Section 9. Conclusion. Respecting the power of nature. Mount Spurr stands as a stark reminder of the raw power that lies beneath our feet. While we cannot control the forces of nature, we can learn to live in harmony with them. By heeding the warnings of scientists, preparing for potential hazards, and respecting the awesome power of volcanoes, we can mitigate the risks and ensure the safety of ourselves and our communities. The story of Mount Spurr is a story of both risk and resilience. It is a story that underscores the importance of scientific understanding, public awareness, and our preparedness to respond to the challenges posed by our dynamic